Yes, so please raise your hand to ask questions live. Yugesh?
Yes. Hi, am I audible?
Yes, we can hear you.
All right. So yeah, I also posted my question on Slack, but essentially I feel like I missed something. I don't understand why format, like data format inconsistencies is related to distributed upgrades in particular. I mean, so the way I look at it, you try to do it on a single node and see that, okay, there is a data inconsistency, and then you just don't roll out that update till you haven't solved the problem.
Yeah, that's a good question. So yeah, so we first, the data format problem also happens between nodes, right? So when there are two nodes running rolling upgrade, and one node is running the old version, and the other node is running the new version. So when they communicate through network message, so we see that a lot of data format incompatibility happens because of this. Yeah.
I see. Okay. Yeah, that clarifies. Thanks a lot.
Yeah.
Any other questions? Okay, Bogdan.
Hey, can you, oh, now I think you can see me as well. Can you hear me?
Yes.
I was sorry, I might have missed that in your talk. Great tool, by the way, and great talk. I was curious how many nodes are involved in these failures. I know that sometimes you can have two, but more complex bugs can have 3, 4, 5 nodes. And I was wondering if how does your application handle that, and what was your experience with reproducing these hard to find failures?
Thank you for the question. So in our study, we found that most of the upgrade failures only require fewer than 4 nodes to reproduce. And in our experience, we build a testing framework that automatically starts a bunch of nodes to perform upgrade operation and rolling upgrade operation. And we found that most of the failures we can find can be triggered with fewer than 4 nodes. But we also found that there are sometimes bugs if a bug requires a specific timing operation, the time interleaving. So for those bugs, we might need to start like 10 nodes to trigger them.
Right. Yeah, actually, that was my follow-up question, but they answered it nicely. Thank you so much.
Okay, our last question. So Jenya.
Hi, thanks. Great talk. So in your talk, you mentioned that you study 8 distributed systems for upgrade failures and their root causes, right? And then you kind of understand that there could be data semantics and inconsistencies with respect to data formats. So for this root cause study, did you have to run the 8 distributed systems on your end and do the upgrades yourself? Or did you have relevant documentation that helped you with understanding the root causes and studying them? How did you perform the study to begin with to build that help building Loop Tester and Loop Checker?
Yeah, thanks for the question. Yeah, so to clarify our methodology that we use in our study, we selected those bugs that have already been resolved, so that it has patches that fix it. Those patches help us to understand the root causes, and also developers' discussions in the bug reports also helps us understand the root cause.
Got it. Thank you. Thanks.
Okay, so now let's move on to our third paper.
Action of the video is because 2 authors will answer the question together, Yongle Zhang and Junwen Yang. Yongle Zhang is an assistant professor at Purdue University working on distributed systems and failure diagnosis. Recently he's actively recruiting motivated students to join his group. So for students who want to apply for the PhD, you can talk to him or email offline. Junwen Yang recently graduated from University of Chicago and joined Facebook. So Yongle Junwen, you can turn on your camera and microphone for questions.
Thank you for the introduction.
OK，千面鱼。
Okay. Can you hear me?
Yes.
So I have a question regarding the DUP checker. So as I understand, serialization library like protobuf or Thrift, they have this field tags that they use to support schema evolution and software upgrades. So why would there still be bugs in the serialization format?
Yeah, I can take this question. This is a very great question. Actually, protobuffs are designed for people to write message and serialize, deserialize, and also support version upgrade. And they have rules for people not to violate. But in practice, especially for our dupe checker, we check the rules protobuf provided, and we found like 800 violations of the rules, which actually will lead to this performance, the data format problems and the upgrade failures. So you can refer to the paper to see what's the 3 rules, but one is that you cannot remove a required field. Another is that you cannot change the tag number of a field. Things like that are actually violated very often by real-world developers.
So is it enough to just check the serialization file, like the protobuf file? Or you have to leverage application semantics?
Yeah, so Dupe check actually consists of 2 parts. The first part is like checking the serialization files, like how they write a proto files, and we check the 3 rules against that. And another part is about the enumeration class, if you added something there. So at that part, we need not only to check the classes whether it has been used in a serialization function. So some data dependency analysis are involved here.
Okay, I understand. Thank you.
Yeah, to add on that, we also found that using protobuf is not very trivial because protobuf has some limitations. For example, it doesn't support polymorphism very well, and developers had to write their custom wrapper around protobuf in order to handle these such limitations, and a lot of errors happen in that.
Oh, okay, that's interesting. Yeah. Thank you.
Thanks, Qianmian's question. The next question, I think, is Zhuo Shen. Zhuo.
Hi, I'm Shen Zhuo from Shanghai Jiangtong University. Thanks for your great talk. And I'm interested in that how often does this software upgrades bugs happens? Because as Qianmian mentioned that there has been many mechanisms to avoid these bugs. And although there will be some errors or incompleteness in this protocol, because such as protobuffs, but I think that they do reduce many of the bugs. So what's the frequency of this software upgrade bugs?
Okay, yeah, thanks for the question. So it depends on which stage you're talking about, right? So so in our study, we included all the upgrade bugs that we can find, and in the bug reports, and we didn't really distinguish them, like when they are. We only distinguish whether they are caught before the software release or after the software release. So typically, before the software release, people do testing, people do software program analysis for bug detection, and but there are still other mechanisms such as canary deployment, right? So a lot of bugs could be captured during canary deployment. One statistic we can provide is that we analyzed those publicly reported bug reports by Google. So those are the most severe outages that happen on Google Cloud. So there are about 66 cloud catastrophic incidents that happen on Google Cloud in about 5 or 6 year period, and 4 out of the 66 are upgrade failures, so about 6%. So considering the catastrophic consequence of these failures, we think it's still an important topic.
Thanks.
Chuan Zhang. Go ahead.
Hi, can you hear me?
Yes.
Hello. Hi, I'm Chuan Zhang from USTC. Thanks for the talk. And my question is, in the last 2 pages in your slides, you have mentioned that the DUP tool chains captures not only upgrade failures, but also the download failures. So in your work, do you find that there exists some difference between the two kinds of failures, the upgrade and the download grade one, or do they just the same because of the mismatched versions of libs or the broken operations?
Yeah, thanks for the question. So to answer your question directly, some of the upgrade failures, as long as you downgrade the software to the old version, it can be resolved. But the example that we showed is one example that the upgrade fails and the downgrade also does not resolve the problem. So in terms of how we do it in our tool, currently we automatically test the upgrade. But if the upgrade fails, we manually check whether downgrade can resolve it. So that downgrading part is not automated at this point.
Okay, thank you.
I think the last question is Yuswen Yang.
Hello, can you hear me?
Yes.
This is Yuswen Yang from Shanghai Jiao Tong University, and thanks for your presentation. So I'm inspired by your Cassandra example. Seeing the application of the new version cannot handle compact storage from the old version. So will there be such a condition that when we use rolling upgrade in the cluster, the node consists of old version cannot handle the data transmission by the nodes consisting of the application of new versions? And if it actually exists, how can we solve it?
Yeah, good question. Yeah, so we actually found many cases they're like this. So during rolling upgrade, when old version and new version they communicate, sometimes the new version simply, so the old version simply cannot understand the data format of the network message from the new version. Sometimes it also happens that one of the nodes transmits a large amount of data through streaming to another node, and the other node cannot handle that large amount of data because they are running different versions. So we did see such examples. Yeah, so we do in our testing DUP tester, we do test rolling upgrade with different kinds of workload, trying to detect such cases. So hopefully, using a better testing technique, we can detect these cases in the earlier stage, so that these bugs won't escape into the release version.
Okay, I see. Thank you.
Thank you. Thank you, Yongle, Junwen. I think this concludes the question. And Lido?
Yeah, thanks, Zhao. Thanks, Junwen and Yongle. So the last talk for this session is on crash consistent non-volatile memory express.